Hi, this is Mrs. Segrist, and welcome to your first lesson in geometry. We are going to be looking at section 1.1 today, which is understanding points, lines, and planes. Some basic general information that you need to be aware of as we go through this year is that geometry sometimes is like learning another language. It is really, really important that you are fully understanding your vocabulary, you're memorizing your vocabulary, and you are understanding the differences between the vocab words. Another thing that's going to be really important in this section and when we get to certain other shapes is naming those shapes. The way that we name lines and points and planes is all very, very important, and it's important that you know the difference in how to name each of these different items that we're going to go through today and in the future. So let's go ahead and get started. One of the first things that we're looking at is a point. Remember that a point has absolutely no dimensions. It's physically impossible to represent a point. But we do it by using a dot. So you can see right here, we have a point drawn with a capital letter next to it. Okay, our points are always named with a capital letter. Okay, so we would name this point P. All right, and if I use a different letter, it would be point Z or point Q or point R or whatever. All right, just know that again, we would draw a dot and a capital letter next to it. That is how we'd represent a point. Okay, if we have 2 points, we can draw a line through them. Okay, so a line is something that we need to understand has no thickness, but it goes on and on forever in either direction. Okay, so if we look here, we have a line drawn. And we will see here point X on the line and point Y on the line. All right. So 2 of the 3 ways we can name this line is by using these 2 points. All right. What I want you to understand is because a line doesn't have a starting point and an ending point, it doesn't matter which point we start with. All right. If I start at X and kind of go to Y, or start at Y, kind of go to X, it's all the same thing because it goes on and on forever. So when I name this line, I can name this as line XY or line YX. And notice that when I do that right here, above it, I draw a line. So I have a little segment bar with an arrow on either end above my 2 letters. All right. The next thing that I want you to notice here is that I have a cursive lowercase letter at the end of this line. Please recognize that this is not a point on the line. It is not a capital. It doesn't have a dot by it, okay? It is not a point on the line. We basically call this in-house, meaning just kind of in my class, we call it a naming letter because it's not actually part of the line. So I can write out the word line and use that cursive letter L to say that this is also line L. All right, so I can name this line 3 ways. I can say line L, line XY, or line YX. Again, the order of those 2 letters doesn't matter. Now, let's say for a minute that I have another point on this line and it is W. Okay, if I put a 3rd point on that line, because remember there's actually infinite number of points on the line, we just only name a few of them. I would still, even with this W here, only pick 2 letters. So I could also name this as line XW or WX. I could also name this as WY or YW. Okay, again, and we're going to draw that segment bar with the arrow on either end. All right, so if I'm using points on the line, I pick 2 letters, and I can write them in either order with the segment bar on top and the arrows on either end. What I want you to notice is that I did not say line L using that naming letter. That's a big no-no. Okay, if you're using the naming letter, you're going to actually write out the word line. Okay, so these are the 3 different ways that we can name a line. Again, we're only going to pick 2 letters. So on your notes next to this box, I want you to write use only 2, and we're going to say points. Okay, so if you use points on the line, you're only going to use 2, never anymore. Okay, the next thing we're going to look at is a plane. A plane is a flat surface. So if you think about your piece of paper that you're looking at right now, okay, and you extend that forever in either direction, in all four directions, okay, front, back, left, right, that is a plane, okay? A plane has no edges, though we draw it with edges just for the sake of drawing it, okay? Now, what we're going to do to name this one is we can either use that naming letter. Notice this naming letter right here is R. It is not, it does not have a point drawn next to it. It is a cursive kind of letter R, all right? And we're going to write out the word plane and R. All right, so that is how we would use the naming letter. Otherwise, we're going to take 3 points that are on my plane. So here I have points A, B, and C. So I could write out the word plane and write ABC. So anytime you're naming a plane, you are actually writing out the word plane. Okay? Now, one of the things that I want for you to either underline or star or highlight is that when we're naming that, it is 3 points that are not in a straight line. Okay? Because a straight line, I can have an infinite number of planes on it. If you think about like the spiral in a notebook, if I turn a page, every page as it lifts up and moves around that spiral is going to hit that spiral if you think about the spiral as the line. And again, we're going to pause this here in just a second and I will show you what I'm talking about in class. But the big thing here that when you're naming a plane is if you're using points, those 3 points you cannot be on a line, okay? It cannot form a line in any way. All right? Go ahead. If you have any questions on that, I will pause now and ask away. Okay. So let's look at our next set of definitions here. Okay? The next thing that we have is a segment. A segment is just a part of a line. It has a stopping point. It has an ending point. It does not go on forever in any direction. Okay, so it's like if we took a line and we took scissors to 2 sides of it, cut it off, that's a segment. So if we look here, my end points of the segment, so that's the points on the farthest, outermost points of your segment, okay? So point A is over here all the way to the left. Point B is all the way to the right. I can name my segment with these 2 points. You always want to use your endpoints, okay? So this is either segment AB or segment BA, because again, it really doesn't matter which way we're looking at this, okay? So that kind of hit 2 pieces of our vocab here as we talked about the endpoint and we're talking about the segment, okay? So when we're naming a segment, again, this is only 2 points and they are the end points of your segment, okay? So that's a biggie here. Now, what is the difference between naming segment AB and naming line AB, okay? If I were to I'm going to dot it so you don't draw this in on your notes, please, but we're just going to kind of look at it for a second. If I look at the line AB, and don't write this down on your notes either, but we're just going to kind of take a look at it together. I would write it like this. Okay, if I look at segment AB, if I just look at what's here to here, okay, then I write it like this. Notice that above the 2 letters is the same figure that we're talking about, okay? So segment AB has a segment bar above it with nothing on either end. Line AB has that segment bar, but it has the arrows on both ends to show the line. Okay. Now, another type of like piece of a line that we have is a ray. A ray is what happens if we just cut off one of the arrows of our line. Okay, so if we look here at this ray, it starts at R and it's going to continue on forever through point S. Okay, so this is ray RS. Now, one thing that's important to know here is your end point, which is the beginning point of your ray, okay? The part where the ray is going to have an ending. Your end point is always named first. So please make a note of this next to on your notes that your endpoint is always named first. Okay, with a line and with a segment. Line AB and line BA were the exact same thing. Segment AB and segment BA were the exact same thing. But ray AB and ray BA are different, okay? So if we look here, we have that ray RS. Notice that it starts at R and goes forever through S, okay? In this second picture here, it starts at R, goes forever through S. Both of these rays are named ray RS, and notice above it we have an arrow. It will always point to the right. Notice that even this one, which has the ray pointing to the left, is still named ray RS. It doesn't matter which direction your ray is pointing. Your endpoint goes first. Any other point on the ray goes second. And your arrow above it will always point to the right because you want it to kind of look like this. Okay, so R doesn't have an arrow, so R won't have an arrow. The arrow goes through S, so the arrow goes above the S. All right. When I look at here, if I look at ray AB, okay, and I put A here and B here, ray AB will start at A and go on forever through B. Okay. If I put those points in the same place and I say ray BA, I'm going to start at B and go on forever through A. Okay, so rays, the order of your letters for rays matters. Okay, this is the only one that we've talked about so far that the order of the letters actually matters. Okay. Next thing we're going to look at is what happens when we have opposite rays. Opposite rays are two rays that start in the same point and then go in opposite directions. So if we look at this, what shape should you see? Okay, you should see a line with 3 points on it. Okay, so what that means is when I have 3 points that are named on a line, from that center point, I have a ray that goes this way and points to the right. I have a ray that starts here and points to the left. So when you put those two rays together, they make a straight line, okay? So they're going to both start at E, and one is going to go through G, one is going to go through F. Both of these, when we're naming them, will start with the letter E because point E is the end point for both rays, all right? One is EF, one is EG. All right, again, we're going to go ahead and pause the video. And if you have any questions about this, since we're watching this together in class, go ahead and raise your hand now. Okay, so let's go ahead. We've got another vocabulary word here, one that we're going to look at quite a bit throughout the year, is a postulate or an axiom, which is any statement that we accept to be true without proof. We're going to get to a lot of things in geometry that we have to prove that they're true. And there are several things that we just assume as fact that we do not prove to be true. It's not possible to prove that they're true. We work in what we call Euclidean geometry, which is a cubic space. There are other geometries that have different assumptions and different postulates, and we're not going to get into that. I will talk about them a little bit later, just kind of as an informational type of piece, but just know that with the geometry and the space that we work in, we're going to assume that these things are true, and there's no way that it's possible that we can prove it. And if you have questions about that, I can hit that in class here in just a second. But when we look at our postulates here, some of these are going to seem very silly, and others you might have to think about a little bit. But most of the times, when we look at it, we go, yeah, I know that. Okay. So we are now going to be looking at the back side of your notes. And what we've got going on here is when we have 2 points, that means there is only one line that we can draw through them. Okay. And just to kind of highlight what I was saying earlier, there are some geometries that are in a spherical space. So thinking like the globe. Okay. If I'm flying from a point here to a point here, I can either fly straight or I can fly around. All of those points are curves because of the curvature of the Earth. All right, so anyway, that's just kind of why we can't prove this is true, because the space that we're working in is Euclidean geometry. And we, again, will not be working with any of the other spaces. But so 2 points, 1 line. Okay. The next thing we're looking at is through any 3 non-collinear. Okay, so first thing here, we're going to make a little note that collinear means a line, and non-collinear means not in a line. Okay, so this is what I was telling you about a little bit earlier, how when we're naming a plane, when we name those, use or pick those 3 points, they cannot be 3 points in a straight line. All right, so non-collinear points, if we draw any 3 points, then there's 1 plane that I can draw through them. All right, the next one here is that if we have 2 points that lie in a plane, then that line lies on, then the plane containing that line, well, those points will be on that plane as well. So basically, if you have a line on a plane, all the points on the line are also on the plane. Okay? And vice versa. The next thing we're going to look at here is if 2 lines intersect, then they intersect in exactly 1 point. So what I want you to kind of do is over here to the side, we're going to sketch what that looks like. So we're going to have a line here and a line here. And when they intersect, they meet at exactly 1 point. Okay. The next one here, if 2 planes intersect and they intersect in exactly 1 line, we're actually going to get a picture of that. If you kind of just look down at the bottom of your page right now, you'll see the picture for example 2. You'll see that you have 2 planes and they're going to intersect to form a line. And we'll get into that again in a little bit. All right. Any questions on that? Again, we're going to go ahead and take a pause. Raise your hands and let me know. All right, moving on along. So let's start working with a little bit of this information. All right, so if we're looking at your paper, you're looking at example 1, you'll see this picture over in that left-hand column and these questions over in the right-hand column. All right, you'll see that it says one name for the line shown in the figure is line PQ. What are some other ways that we can name line PQ? Well, the first way is by switching the letters. So I can say line QP. Okay, because remember, those are the same things. The other way is I can actually write out the word line. And then again, I've got this naming letter, which is a lowercase letter at the end of my line. Okay, it's not a point on the line, so I can say line M. All right. Part B says if we just look at PQ, so that means that what I'm going to do is I'm going to ignore this piece and I'm going to ignore this piece. And you do not have to do this on your paper. I'm just doing it for our purposes of kind of looking at it. Okay, so we've got segment PQ here and we want to look at another way to name it. Well, another way to name it is segment QP. And again, notice that when I'm naming the line, I use the arrows. When I'm naming the segment, there are no arrows. All right. Every now and then you will see me write out the word segment and then QP or PQ. It doesn't happen all that often, but please know that that is another way that you can use it. We just don't use it hardly ever. Okay. So what I want you to do is look at question 1A, and it says, why does the order in which you name the points when you name an array matter? So you want to use points P and Q in your answer. So what I want you guys to do is to take a minute. We're going to pause the video, and I want you to answer this question in your own words, and then in just a second we will go over it. So I'm going to pause the video now, and then go ahead and answer this question. Okay, so let's take a look. So you may have this written in your own words, and that's fine. But if what you have doesn't match what I have up here, please make sure that you kind of fix your answer. So when we look at ray PQ and ray QP, the rays are going to point in different directions. Okay, ray PQ has P as an endpoint, and ray QP has Q as an endpoint. All right, so ray PQ will start at P, go through Q, and ray QP will start at Q and go through P. Okay, so please keep that in mind when you're naming rays. All right, now you will notice underneath that there's a little box on your notes that says questions you have about example 1. We're going to take a second to pause, and you can ask me any questions that you have right now. But when you are at home on your own in the video, this is where you will make note of any questions that you have of anything that I talk about. That way, when we come into class the next day, you can ask me those questions so you don't have any confusion over any of the material. All right? So let's go ahead and move on to our last example here. Okay, we're looking at example 2. Notice that I have a blue plane that is vertical and an orange plane that is horizontal. Okay, so we want to look at the intersection of the two lines that are in this picture. So we want to find our two lines. So here's one line and here's another line. Now what's kind of important to see here about this is when you start drawing all over the place, when you start seeing dotted lines, that means that is hidden behind something else. So like back here, this back side of the plane is hidden behind the vertical one. It's to help you see the three-dimensional aspect of your picture. So this line is running along this blue plane, okay, running vertically. This line is running horizontally, all right? So the intersection of the two lines. So here's one line, here's another line, and where do they meet? They meet right here at point C. All right, now notice that there is not a dot right here on top of C. It is understood that when you have an intersection, this is a smaller point, so it's more accurate. All right, so C is this point where these two lines cross. All right, now we want to look at the intersection of the two planes. So if I look at this whole vertical plane and I look at this horizontal one here, remember as we're looking at this, that a plane, even though we've drawn them in with edges in our picture, that they don't actually have edges. So these planes go on forever in all directions, okay? So what you need to realize is while you see B and D here, and those two planes meeting at this segment, that's just where the picture of the plane ends. It goes on forever. So where our two planes intersect is actually the line, okay? So planes will always intersect in a line. So we can name this as line BD. And you only have to write down one answer when you're doing your work, but we're going to go ahead and write our other options down. But again, when you're answering a question, I only need one of these. Okay, but I can name this as line BD. I can name this as line BC. Or I can name this as line CD. And remember, I can flip any of these letters. So BD or DB, BC or CB, CD or DC. Okay, they can be switched. And that's not a problem. Okay, but those are the three distinct ways to name this line. Notice there is no naming letter at the end of the line. All right. So for part C, we want to name the horizontal plane in two ways. So our horizontal plane is our orange plane here. Here we have a cursive capital letter F. That is our naming letter. So I can name this as plane F. Okay, so that's one option. The other option is to name the plane using 3 points that are not on a line. Okay, so here's why we cannot use 3 points that are on the line. All right, we have 4 points on this orange plane, B, C, D, and E. Okay, B, C, and D are all in a straight line. But aren't those 3 points also on this vertical plane? Okay, they're on the orange plane and the blue plane. That's why naming 3 points in a line does not distinguish one plane because multiple planes can go through that line. So we have to use the letter E because it is the only point of these four that is not on the line. Okay? Then we pick two of these three letters. It doesn't matter which two, so we're just going to pick B and C. Okay, so plane E, B, C. Those 3 points you cannot draw one line through. All right? So we could have, but as long as you use E, you could do ECD, EBD, it won't matter, but you have to use the point E. All right? Now, looking at the last one, we're looking at a pair of opposite rays. Again, remember, opposite rays are going to start in the same point. One's going to go one way, one's going to go another way, so that really what they form is a line. So what we're looking for is a line with 3 points on it, okay? If we look at this line, notice that I have point A and point C, but I don't have another point down here that's named. Okay, so I cannot use this line to find opposite rays because I need to be able to name it, and I need 3 points to be able to name it. So we're looking at our other line here, okay, at line BD. C is in the middle. So that means I have a ray that starts at C and goes through D, and I have a ray that starts at C and goes through B. Okay, so I'm going to have ray CB and ray CD. Notice again that C is that initial point for both rays, okay? So that has to come first. And again, our ray is always going to point to the right. All right? If you have any questions about that, I will go ahead and answer them now. Again, if you notice on your notes, you see a little box where you have for questions. If you have any questions, go ahead and you can write them down or ask me. But that again will be where you write your questions for your homework when you're watching these videos at home. Okay, I hope you guys enjoyed this video, and we will answer any of your questions that you have now.